This is the last session of the day, and we're going to try and get through as many of these lightning talks as possible. Now, who here has been to lightning talks at the Open Programming Miniconf before? Okay, so for those of you who haven't been to one of these mini-confs before, it works like this. You get 5 minutes to talk on a topic of your choosing. That 5 minutes starts from the moment you attempt to plug your laptop into the projector.
Unless you know this and cheat by signing yourself up first.
So, with that in mind, note that Paul Lepardi is second and Dave Boucher is third. So get yourself ready to come up on stage as soon as possible so that you don't lose time trying to fiddle with the projector. Our first presenter is Adam Harvey, who is going to be talking about micro-PHP. Your time starts now.
Thank you very much. Hello, everyone. There is no countdown clock. This is very disconcerting. I would like to talk about... Beautiful. I'd like to talk about the fact that a lot of people use PHP to write websites. Most people seem to use PHP to write websites. There's apparently no accounting for taste. Not all sites are Facebook. Not everybody really needs a... most sites aren't Facebook, actually. So realistically, of course, what that means is that we've got all these wonderful full-featured frameworks in PHP. You know, there's Symfony, there's Drupal, there's WordPress if you like pain, there's Joomla if you like deprecation errors. So there's a lot of options, but the reality is that a lot of them produce a lot of bloat and they replicate things that I think you can actually do more simply just in really a simpler framework. Now, other languages have this concept of a micro framework, and it's something that's also made its way into PHP. So a couple of years ago I saw a talk at PyCon AU by Richard Jones, basically the state of Python micro frameworks. And the thing that was striking was he defined a Python micro framework as, I believe from memory, under 1,000 lines of code. So I decided to see what was out there in terms of PHP micro frameworks, because a lot of the time you just need to whack a web service together or set up a rego form or something like that. So I did what everybody does and I typed PHP micro framework into Google. These were the first three options. I would have gone further down the list, but it's a 5-minute talk. So, number one is Silex, which is by Fabien Potencier, which I've just mangled horribly, who is the person behind Symfony and pretty much everything else. Silex, basically a very simple Hello World Silex application looks like this. You can see there that there's not really much to it. It's very short, it's very clear, it's got the micro framework virtue of, being very obvious and easy to read. There is, however, one slightly disturbing part, which is the auto-load line, because what that means is that we're actually pulling in an indeterminate amount of other code via an indirect method that PHP provides for class inclusion. So I decided to run the tool I love using to estimate how much I'm actually worth at salary negotiation time, slot count, and figure out how many lines of code there actually are that are being pulled in. The answer is 33,086 physical lines of code. So it's not counting white space or comments or anything like that. There's 33,000 actual lines of PHP code being pulled in. Now, let me just go back to those Google results. The PHP micro framework based on Symfony 2, a PHP micro framework, etc., etc., etc. Micro.
Yeah,
are there any children in here? What the fuck? I mean, really? Okay, so let's see if things get better with number two. So number two was Slim. Slim looks really, really, really similar in terms of how you actually set it up. Again, there's an auto load, and this time it's 6,000 lines of code. It's Slim in about the same way I used to be. Number three was Flight. This looks fairly familiar, 812 lines of code. So this is actually an improvement. This actually is the first one that seems like it's a real micro framework.
90 seconds left.
Thank you, Christopher. So, I did this highly technical analysis and came to the conclusion that number 4 would clearly have a negative number of lines of code. It turns out that's actually not true, which really disappointed me. So I decided to write my own PHP micro framework this afternoon after my first talk. It's called PHP because it turns out PHP actually is a surprisingly effective framework. You can write your own router and fit it on a slide and possibly have it be readable for the first 6 rows or so. I mean, it's really not that hard. My application code looks pretty similar to the others. Okay, the regex is a bit messier because I haven't implemented any sort of like pretty string handling, but it's not too bad. But what if you want templates or MVC, I hear you all say? But Adam, it's all about structure. Well, you can have templates because it turns out, and this is a real surprise to me, PHP is a templating language. That's what the template looks like. And if you need a model, it turns out PHP has database objects. Who knew? So all I'm saying is, next time you need a simple little PHP site and you feel the need to import 33,000 lines of code, remember that we've already written about that much and simplify.
Okay, so up next we have Paul. His time starts now.
Okay, let's see whether or not we've got something that works. Yes, okay, good. Okay, cool. Mouse goes somewhere. Mouse. Yes. Okay. Right. IPython. That's IPython. I'm running a Python interpreter. I have a tutorial that I have prepared earlier, 0.2. Tutorial will blurb through for a while. Blurb, 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 enter to continue. Exercise, enter a Python statement. Okay, so who here can see that this could possibly be dangerous? Python statement could be anything. Set y equal to well, not quite. It tells me there is another way of doing it, blah, 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 etc., etc. So what's going on? What's going on is that, if I can get this cursor to work, is that I've created a very, very small framework, and the very small framework is this class, if I can get down to it. Where is the class? Yes, okay. Class called interaction context. Okay, so who here can remember that Python has something called exec? Okay, right, so Python has something called exec, Python has something called eval, and Python also has dictionaries, and one of the dictionaries is the Dictionary of Global Variables. So very simply, if you want to write a tutorial where you get your user to input either Python statements or Python expressions, what you do is you take a copy of the globals dictionary, which has the current state of the program. You use that as a sandbox. You get either your eval or your exec to operate against that. You check the variables against what you expect them to be changed to, and that's all you need to do. So what I'm trying to say is you don't necessarily need to have a very elaborate sandbox in order to set up a tutorial for your users where they actually enter Python code. You just need to have something that takes advantage of those few primitives that are already built into the language. And that's it.
Great, thank you. So up next we have Dave Boucher, and following that we have Thomas Sutton. Great.
To do anything?
As soon as you plug it in. Your time starts now.
Right, so I'm giving a presentation on Thursday. It's going to be a great presentation. It's on software transactional memory. And so, towards the end of last week, when I was thinking I should start working on that presentation, one of the classic use cases for transactional memory is tree insertion. Because it's really hard, especially in something like a red-black tree, to lock a tree and do an insertion and have parallel inserts going on. I'll get back to data and currency. So I was going to talk about red-black trees and insertion. And as part of that, I thought, well, wouldn't it be cool if I could actually have a graphic that showed graphically the insertions happening to a red-black tree. So instead of actually working on my presentation, I spent 2 or 3 days fooling around with how can you actually build a cool graphical representation of what goes on in a red-black tree. Thus the yak shading. So I just grabbed the code out of the kernel. Got to give some attribution to Woodhouse and Andrea. And I just added some statements to it. So whenever it did something useful, like move a node from here to here, I just added some print statements to print out, hey, I'm setting the color of the node, 19 to red, and I'm moving this thing from place to place. And that's pretty cool. And so it produced this little moves file that said, hey, create a node, give it my own little internal coordinate scheme, move the nodes around, send to red, send to black, and so forth. What was really cool, and the reason I'm standing up here, is I don't know how many of you have played with scalable vector graphics, SVG. They're super, super cool. If you ever in the old days tried to do typical blit generation of graphics, it's horrible, right? I mean, using the libraries and Qt or whatever it happens to be, or Canvas, it's really horrible building pictures. But SVG is actually, and there's a lot of people who don't like XML, but it's this XML-based, character-based language. If you open an SVG file, it's perfectly readable. Well, for some definition of perfectly readable, but it's readable. It's certainly writable by a human. So, and there's a really cool PySVG package which wraps that all in classes. So you can do things like the top line creates an SVG class, it gives it a view box, whatever. I mean, this is all, there's not a lot of code that has to wrap around this. You can create a line, you give it an AX, AY, BX, BY. I started out at hidden, I'll show you why in a little later. You can create a circle, you can create a text. This thing down here actually groups the circle and the text. You can maybe see where this is going. My tree has little circles with numbers on them, which is the units of the tree. You can group those together. You add these things together. So here I'm adding the circle and the text to my little inner container object. And then I add the outer container object to the page. I mean, it's pretty straightforward. SVG also, which is hyper cool, has animations. So you can say, I'd like to move this particular object from here to here. I'm going this fast, and so on and so forth. I started to get fancy, which is why actually during Daniel's talk I was still working on the presentation I'm giving on Thursday because I kept refining this. So you can make it, the spline thing says instead of just doing a linear interpretation of moving from here to here, I want you to accelerate and then decelerate so it actually looks a little cooler as it's moving.
1 minute.
Which is fine. So this is sort of the XML that comes out, and so if I run this thing, this is an SVG file, it's actually a single self-contained SVG file, which shows what happens when you insert stuff into a red-black tree. And it'll get a little more interesting in a second when it starts doing some rotations. Anyway, so this took me about, 2-3 days to do. It wasn't that complicated. And actually, it's pretty freaking cool, actually possibly more interesting than the actual software transactional memory talk that I'm giving on Thursday, though I would encourage all of you to come to that talk because it's going to be freaking awesome. As soon as I finish it, I promise it'll be great. So, that's it. Thank you. Not done. Oh. No, that's okay.
Okay, so Thomas Sutton is up next.
I'm out.
And Roger Barnes, if you are up after him, so yeah. Your time. Now.
So you're probably all sick of hearing about Haskell and Clojure and OCaml and Erlang and all of
Use the
those
mic.
languages. Here's some more. This mic? Yeah. So I'm going to be talking about safe string APIs, or safe string handling in Haskell APIs, or rather some safer string handling, or to be honest, it's really kind of safer-ish, because it doesn't do enough for me. So those who don't know Haskell or of Haskell, it's a purely functional language, but it's fairly pragmatic. We heard about concurrent programming. It's true, Haskell is extremely good at scheduling I/O, and you don't write code that looks like Node.js code. It's strongly typed, and that's what I'm going to be doing here, and it's kind of pretty safe. I wouldn't call it safe because it's still possible to crash Haskell programs, but it's a lot safer than something like C. So strings in Haskell look a lot like this. You might have a variable, you can't change it, but it's a variable. A string, it's a string. The syntax looks like that. In GHC 6.8.1, they introduced a feature called overloaded strings. So you can actually overload the string literal syntax and write string literals in your source code for other data types that aren't string. Because let's face it, who actually wants a linked list of Unicode code points as their basic representation of text? That's not fun. Doing it looks like this. Normally, if you want to use text, which is basically what you use in C, it's an array of packed bytes in memory, great for memory utilization, much better than a linked list anyway. It looks like that. You have to manually, where's my cursor? You have to manually pack a string into text. So it's actually slower to do this than it is to just have a string. Using it's going to be faster, but just having a variable with text in it is going to be slower. Until you do something like overloaded strings, where you get to use nice string literal syntax, and the code is nice and readable. All you've done is turn on a language feature. That's cool, but so what? Well, doing this means that you can do things like have your very own data type to represent things that would ordinarily be strings. Things like SQL commands. And you can control the API of those because it's your own data type. So you can say, I want to have some string things that contain, say, SQL statements for my API, but you can't concatenate them. So you're minimizing the chance that some developer is going to write an SQL injection vulnerability. There's a bunch of libraries that use this technique. One of them, the one that pioneered it, is called MySQL Simple. It's a simple access library for MySQL, written by a guy called Brian O'Sullivan. Really, really clever guy. And the code looks like this. This code doesn't compile because I'm passing a string into the query method. You get an error that looks very much like that. The query function needs a query value, but you're giving it a string. You turn on overload strings, and it compiles and runs. Awesome. Then you do things like this, which, I mean, really, if somebody can change the value of op, they can change the entire meaning of the query. You don't know that the developer is going to write processing code to handle that case correctly, so you don't do it. It doesn't work. You cannot concatenate strings together and then pass them through to this library. The only downside is that all of the code that does this is public and you can import it. So in actual fact, they can write that. It just takes them an extra 10 lines, characters of code. That's not good. So what do we want? I want to do something like this. I want to be able to say, secure print is my operation. You pass it a string, it works fine. I want to say, you can even concatenate together static strings and pass them through. That's fine. That should run. But if you read a variable in from the user, and you try to use secure print on it, that should not work, because that is not secure. Users lie, they're wrong, don't do it. And if you concatenate together static values and input values, that should also not work. So basically what we do, skipping along very quickly, is use the optimization framework. When you compile that code, it looks like that at the bottom. You can use our own private data type. We've got a secure print operation. It prints out, and by default, we say that's an error. You can use optimization rules to replace that with a slightly our own safe or our own unsafe version saying it is an actual error. And then you can even go a little bit further and replace known good calls that have used the internal string variable functions and replace them with a known good version for static.
And that's your time. It's a nice background.
All right. Drum roll.
Hey, hi, my name's Roger and I've just wasted a lot of time. I'm actually trying to compress a 25-minute talk into 5 minutes, so I needed those seconds. I'm going to talk about the adventures of poker, packets, pipes and Python. That's really hard to say. So I like playing online poker just for fun, you know, not for money. That's really scary stuff. But I'm not necessarily very good at it, which is also why I don't play for money. So I had this game that I play, and I wanted a poker buddy, something, something that would help me. I'm making a mess of this one. Something that would look at my cards and give me some hints about, you know, how I'm doing. Keep this configuration. So this is the game I play. It's an Android app, and basically it talks to a network server and other people play, and that's what I was basically trying to explore is, can I get about how I'm playing based on the information I have, which is basically just my cards. So I wanted to do some exploration. I was thinking, well, packet capture could get us somewhere. So there's a few ways you can do that. There's TCP dump and all sorts of things. You can actually get an app on your Android device that'll do that if you rooted it, which is pretty cool. Or if you've got your router and you're using Wi-Fi, there's a whole lot of things you can do there. There's TCP dump, there's T-Shark. In the Python world, there's one called pcappy, and ngrep is really nice. It's like grep, but for network packets, and you can sort of bypass some of the bits of packet information that you don't really need. There's lots of hackable routers out there. I've got one that's got Tomato USB running on it. You can SSH in, you can install a whole lot of stuff using Optware, which is really cool. And you can install Python, you can install ngrep, all sorts of things that will come in handy for this exploration. So at first, I didn't know anything about this application and how it communicated. So I thought, first of all, I'll do a packet capture. I figured out my IP address for my Android device and what ports this game was using. And lo and behold, having gotten that information, it's not encryption or anything to worry about. So now I have a nice name value pair stream of information about what's happening in the game. So this is looking pretty plausible. So what I did then was I had to pull apart that information. Python has an application called IPython. It's really good for exploratory computing. And that has a notebook module on the front. And you're using your web browser, you can explore, and you can especially, well, it's especially useful that you can save this information and basically have a documented exploration of what you run. So you run code, you save it, you get the results and everything all stored together. It's well worth looking into. So basically I use this to parse game state, figure out what card values meant, what different actions there were in the game, and I came up with a couple of little bits and pieces that would map cards. So given card number 44, that turned out to be the 7 of spades, that sort of thing. So now I was trying to string all this stuff together, and I wanted live capture data because it's no good getting hints about a game if you only have 10 seconds to make a decision. So I went through a few options there. There was a whole lot of different problems with installing things on routers, installing things locally, getting pipes and everything together. How am I doing? 1 minute. I'm going to skip ahead a little. Running hand analysis was something that I also had to do at some point. So my solution was to have my laptop and the Android device connected to the same access point, and I would just SSH to my router, get it to ngrep the data back to my laptop, and I would just pipe it into my Python program. Pipes this is pretty standard stuff. You read standard in, no problem there. You do need to watch out for buffering, so if you want a result quickly, you want to not be blocking on sizes of packets and things like that. Not packets, pipe buffers. And then we needed some poker smarts, so I could write some stuff. There's lots of lookup tables online that you can use. In particular, it's quite handy. You can just dump lookup tables from Wikipedia, for example, into a big string. Don't even worry about parsing it until you actually get to your Python program, and then just write some massive list comprehension, I love these things, that converts it into a lookup table, and it's all just there, and you can still read the bit above it. There's also very specific things you can get. There's a thing called PyPoker eval, which is awesome.
5.
Okay, and 1%. I shouldn't have played that hand.
And that's your time.
Sorry.
Wait. There you go. Okay, so Benno Leslie now, followed by Miko. What are you looking for?
Screen up.
Oh, you're the screen guy. Your time starts now.
Hey, I haven't plugged in my laptop. I thought I'd get to fully cheat this system. Okay, so how many people here use Python on a kind of regular basis? Okay, and how many of you guys use Haskell on a kind of regular basis? Not so many. So the next is going to be interesting. Who here kind of uses Python and Haskell on a kind of regular basis? Okay, so this talk is for those 4 people. Everyone else, you don't really need to worry. So earlier today we had a talk on embedding everything in everything, which I think is a really cool idea. So what I want to do is take that just a step further and be able to embed some Haskell code in Python. So why would you want to even consider doing this crazy thing? Well, I first started writing Python code probably 15 years ago now, which is about the same time I first started writing Haskell code as well. Back at that time, Haskell implementations weren't really up there in terms of I/O and that kind of thing, so you're pretty limited in what you could do in terms of I/O. I think the whole I/O monad thing had only been invented a couple of years ago, so there wasn't really much in terms of I/O. So in those intervening years, I've done programming and not so much of the Haskell programming. But as you probably know, if you read Reddit or Hacker News, all the really cool programmers, like these 10 that put up their hands, are using Haskell these days. And I think I'm pretty cool. So what I did, I went and bought this hat, and then I started writing Haskell programs again. But it turns out that writing Haskell programs is kind of hard sometimes. And especially that I/O monad thing. And after 15 years of regularly using Python, I've got kind of good and kind of fast at doing that. So what I really wanted to do was do all my pure, nice computationally pure stuff in Haskell where it really made sense, and do all that messy I/O stuff in Python where I've got a whole bunch of libraries that I'm used to and I can prototype really quickly. So what I really wanted to do was use both of them together. So turns out it's not actually that hard. Whoa. And in fact, it fits on a whiteboard. So let's start with the Haskell stuff first. It's this bit down here. We're creating a really simple module just called test, which is this line here. And we're importing one of the Haskell libraries, foreign C types. That lets us talk about C types in Haskell. Then we've got this magical line here, foreign export C call. And what we're going to export is the fun function, which takes in a C integer and returns a C integer as well. But of course, because this is Haskell, that's actually on the I/O monad because it's not really safe there. And then we go and implement this. This is just repeating that same type declaration again. Any of the Haskellers could probably tell me whether I can just completely omit that, would be nice. And our fun function is really simple. It takes the input and adds 42 to it and returns it. So what I want to do is call that function from Python. Turns out that's really quite simple. We, from the C-types library, import CDLL, which we then use to create a Python stub to the DLL, which encapsulates all this code. And then we can simply call lib.fun5, and that should print out 47, I think. And that's basically all you need to do. So if you like Python, you like Haskell, you can combine them together using foreign C types and C types in Python. Thank you.
Okay, so Miko's up next. Yes, well, there's an O. That's an O. Look.
Miko.
Oh, really? Okay.
Miko.
And then Duncan Rowe is after that. So if you could be ready to present next, that would be fantastic. I'm just going to wait for you to attempt to connect your laptop.
Sorry.
He's stalling a lot. Should I start a timer now?
Just go ahead.
Okay, so your time starts now.
Okay, this is about a system called Laprock, which is a library for tools for process control, and a language called Clockwork, along with some code we've written for an Arduino to connect Clockwork to that hardware. At this point in time, it's used to control machines that sample wool, and hopefully we'll get some sound. So that just cuts a bale and takes a very large sample of wool out of it, and the gentleman there goes and picks it up. And further up, you've got a machine that takes a core sample, a bit like earth samples out of the ground. There's about 30 seconds of this. And I've got a simulated demo of the actual code, which if I go to here, we have a web page here, we have a cylinder. It has an extended input, a retracted input. It has an output for the to extend it and a output to retract it. And then we have this simulated cylinder here. I can say up, and it goes up, and you'll see that retracted turns off and extended turns on, and back the other way. So that's a simulation of that device, and the code behind that is reasonably simple. If we could just get, maybe I've got this a bit big for us. I wanted to make it so you could read it. Is that too big? Oh, that's good. Okay. So there's a class of a machine. It takes 4 inputs. We have 4 states, which is extending, extended, retracting, and retracted. It takes 2 commands, which was those buttons I pressed on the web page, and on receive, on enter of a state, you can run some commands that will extend and turn off the input. And the configuration is fairly simple. I've simply created some flags and true on-off flags so that I don't have to connect to real machinery. So we've got the definitions of the flags, the definition of the machine, and the definition of the simulations. And it's a full-blown event state-based language designed to connect to almost anything. It can take data from 0MQ channels, MQTT, which is a protocol from IBM for simple microcontrols and those sorts of things. And we have it talking to video cameras and scales and all sorts of stuff. So, and as we said, the website for it is just there on GitHub under Laprock. So hopefully you'll find it interesting.
Wait. Need to do that first. Okay, so now we have Duncan Rowe, followed by Russell Stewart.
This is about little commands that I've developed over the years. I'm not a fast typer, so I like to have as many single character commands as possible. This is my bin directory where they mostly are, and the rest of them are contained in my bash RC, which I haven't really got time to show you. There's several families of commands. PD is my directory navigation system where you just, rather than use CD, use PD, and you build up a list of where you've been, and then if you want to go back to any of them, you can look at the list, and then you can just go by number to the one you want. So here we are in include, and another family of commands are the families that searches for tokens or strings in directory trees without having to type all the find command and everything else. So a common problem came up the other day on the Express Exchange. What's buff size? Well, if we look for buff size inside here, which I've managed to escape U. The SFL is part of the family. That's the one that looks down a tree. FL by itself would have just looked in the current directory. Well, there's the matches on buff size coming up, and there's a hash defined in there, and it's underscore IO buff size. So we check and chase after that. And that'll come up shortly with one match that's useful, underscore G underscore. So look for that. Oops. And that should find. There we are, 8192, finally got it. That's the cursor, there it is, 8192. Family of commands is quick renames, because you've got something, you don't want to check it into RCS, it's not really what you want, but you want to throw it away just yet. So you might want to rename it to be .backup or .old or .new, depending what it is. So there's a whole family of like if I have a command, something that like there's like BU, so the basic original for backup is an old thing from the general days. But if you BU something, that will or say you back something, it's the same thing. So if I back a file, it'll rename it to .back. There are various things I can do with .back. I can CM back with the original, which won't work because there isn't an original, but I can unback it to change it back to what it was, if that's what I want to do.
10 seconds.
And I can RM back to remove it. And then there's a family of those for .back, tilde, .bu, .reg, .new, and the rest of them. Okay.
So, thank you for that. So Russell Stewart is up next, followed by Peter Chubb. Those business cards will eventually migrate into plain view.
No, I don't actually have a...
Oh, no slides. You shouldn't have said that. I've started your counter.
Thank you, Chris. I'm here to talk about PAM-Python. Actually, what triggered this talk was the embedded thing, so it's obviously spurred a few people on. In the process of it, I'll get to talk about PAM-Python itself, which is good because I wrote it. So, who here has used PAM? I would hope most of you have used PAM. Who here has written a PAM module? There's a couple. Oh, good. So, for those of you who don't know the programming model of PAM, it's what I guess the Gang of Four would call the bridge pattern, where you have a plugin on the top edge and a series of modules on the bottom edge. So on the top edge you would have maybe login is trying to authenticate the username and password. And then the system administrator gets to say how he wants to do that. So he might want to use just the conventional Unix login system, or maybe he wants to use a YubiKey, or maybe he wants to use Kerbos. It's a fairly straightforward pattern. It's all done in C for speed, I guess. It is fairly flexible. It doesn't just manage passwords, it manages sessions and a whole pile of other things. Now, I'm not going to explain Python. I assume you all do know what Python is. So why PAM Python? Well, being an upper and lower edge C thing, in order to write it, you have to write C. And having upper and lower edge means that there's all these things about who owns what block of memory and why, and who's going to free it. And in fact, it's not even consistent about how you do that. Some places the upper edge owns it, but the lower edge has got to free it, and so on. So if you think about the sorts of programs that use PAM, they're unimportant ones like login, SSH, sudo, Apache. Programs which you really wouldn't care if you sideloaded a string corruption problem into them, or a Stack Overflow problem into them. So thus PAM Python is born, because I had a number of modules I wanted to write, and I didn't want to have to be that careful. So I wrote a module that will load a Python program and allows you to write your PAM application, so you can check your YubiKey or go to Kerbos or NNTLM and do it purely from Python. And it's rather nice because, you know, when the Python interpreter exits, it cleans up everything, so all your files are closed. You don't have to remember to close it or anything like that. You don't have to remember to free any memory. In fact, it's remarkably good. All references just disappear. So, but after I'd done this, I realised what I'd done. Now, I don't know when anyone here has looked closely at the size of login, but the size of login is 38K. Now, I don't know what anyone has looked at the size of the Python interpreter, libpython, whatever, but it's several megabytes. So what's happening, totally unbeknownst to the programmer who wrote login, ultra-quick, clean C code, is I'm underneath him and he's not aware of this. I've loaded in the entire Python interpreter, run a few lines of Python, and then got rid of it. And I've done this on all the programs that are meant to be secure and fast in Linux. And I thought that was an interesting case for embedding because they didn't know it was going to happen. Thank you.
Okay, so our last lightning talk is Peter Chubb.
Yep. See if I can get this thing right here.
And your time starts now.
Yeah, they're not very expensive. They've got a swag load of I/O ports, and they've got a really nice programming environment and hundreds of libraries you can play with. Sometimes they're not enough. So you go to TI and you buy yourself a Stellaris Launchpad. This has got an ARM Cortex-M4. It's got considerably more memory. The programming environment isn't so nice, but the price is right.
Sorry.
$12, including shipping, approximately. No, that's for the development board. And the development board is very nice in that it actually has two Cortex-M4s on it. One acts as a JTAG emulator for the other one, with a USB port. What's more, it's got some wires you can break and use that as a JTAG emulator for something else. So you can get your ordinary 20-pin JTAG out for doing some other board. Sometimes that's not good enough because the problem with both of these is they don't run Linux. And we're a Linux conference. So you can buy yourself a Raspberry Pi, $35 approximately. It's got significantly more memory, but it doesn't have any flash. So you're stuck with one of those SD cards which are really, really, really slow. One possibility is to buy yourself an eMMC adapter instead of your SD card. They run about 100 times faster. And they're not that expensive, about $50 for a 16 gig card. But $50 plus 35, you're up to like $85. So it's a bit much. And if you're going to pay $85, why not go to the Odroid U? This is about the same power as a PC. It's quad-core, running at 1.7 gigahertz, has 3 gigabytes of memory, and it's about the size of a credit card. And it costs you $69, including postage. So, next time you're tempted to grab an Arduino to solve your problem, try looking at some of these other ones instead.
Great, thank you very much. In the first weekend of July down in Hobart. I'm partially responsible for that, and I highly encourage you to get down there if you've enjoyed all the Python content that's been happening during the lightning talks and during the rest of the day. Love to see a whole heap of you down there for that. And I guess to finish up, we've had a really great array of presentations today on what I think is probably the wide range of topics we've had at one of these open programming mini-comps in the 4 years that we've run it. So I'd really like to thank the presenters for giving us so much interesting developer-related stuff today. So thank them. Also to all the people who just presented lightning talks, I'm sure they hadn't planned on giving a talk today until sometime later this afternoon. So it's great that they've put together so much interesting stuff. So thanks to them as well. And just on behalf of myself, thanks to the AV people who've been really good today. They've made sure that everything gets recorded and that you can hear everyone. And they also stopped that annoying beeping sound during the second talk. So thanks to them. So yeah, that's it for the Open Programming Mini-Conf for this year. Hopefully we will see you back here, or sorry, wherever the LCA ends up next year for another Open Programming Mini-Conf. Thanks.